Hey, here we go. Loved about the constructions last Friday. I loved reading through your papers where you wrote about 2 things that you learned and then 2 things that you were still wondering about with mid segments. So can anybody remember, I know you've had the whole weekend, can anybody remember something you learned about mid segments when we created them last week? Tyler, what'd you learn?
Middle triangle they make is like half of the big triangle.
Perfect. He said the middle triangle is half of the big triangle. Makes me a tiny bit nervous. You need one vocab word in there. What's half of what? Starts with the letter P. You can shout out, guys. Perimeter. The little triangle that's half of the big triangle, the perimeter, right? What else, Ellie, do you remember?
Yeah, I thought it was cool how like if the big triangle is obtuse, the little triangle.
Oh, so Ellie remembered that if we had an obtuse triangle, the triangle created in the center by the mid-segments was also obtuse. How many remember that? Do you remember seeing that? Okay, let's get one more thing. One more thing that you guys remember from that activity? Colton, you raise your hand.
Yeah. Like if you have a acute triangle,
Mm-hmm.
one half of, like the leg or a base of the triangle equals one full length of the small triangle.
I love that. I'm going to draw a picture of what you just said. So he talked about in a acute triangle. Colton remembered, guys, if this was 5, what was this whole thing? That's a big concept on today's notes. Way to remember that. Okay, let's go to our first vocab, and it's mid-segments. So there, if you're a word person, I typed in the definition. If you're a picture person, you can draw a picture too. Remember, these are your notes, so you know how you learn. Hopefully you know how you learn. Do whatever's best for you. So remember, a mid-segment connects the midpoints. I'm just going to draw an acute triangle for those of us who are picture people. So sketch an acute triangle, and then first we had to find the midpoints of every leg. So we're just going to eyeball on today's. Pretend that's the midpoint. And then maybe right here, that's the midpoint. And then maybe right here, that's the midpoint. Okay, stop. Am I done? Have I created the mid-segments? No, now you've got to connect the midpoints. That's the mid-segment. So a midpoint to a midpoint, that's a mid-segment. So from here to here, here to here, there's 3 mid-segments. Perfect. How many of you are like, oh yeah, now do you remember? Yeah? Okay. Alright, moving right along. Okay, whew. We're going to get into some deep stuff. However, it's also a review. We're going to review slope and distance formula. Distance formula on the vocab, on the board wall. Also on your CRT reference sheets if you need it, and we can write it in our notes first. Okay, right here in the directions, guys, will you circle this? First, we have to show that they're parallel to each other. You can do that by finding their slopes. Okay, what I want you to do is turn and whisper to your neighbor. 2 slopes are parallel if, go, whisper to your neighbor. 2 slopes are parallel if, perfect, guys, tell me, 2 slopes, wait, what am I trying to say? 2 lines are parallel if their slopes are? They have to be the same, exactly the same. Okay, everybody pretend like you're holding a balloon that has helium in it. All right, and you're a little kid. Little kids, what do you think they do with balloons? Okay, let go. Where does your balloon go first when you let go? It goes up, and then the wind catches it, and then it's gone, right? That's how I teach my 7th graders to remember about slope. It goes up and then over. It's like you're dropping a balloon. So if we're going from F to G, you go up first. Pause. This is a big deal with my 7th graders. Do we count this as 1? No, you count your movement. So your movement is 1, 2, 3. So up 3 spots. You can write right on that graph. I do not mind. Okay, so we've gone up 3. We've dropped our balloon. Now the wind caught it. Do we count this spot right here? Count your movement. 1, 2, 3, 4. Okay, my poor little dears will write this. They'll put slope of FG is 3, 4. Do you agree with that? No, that's a point, that's a point. That's not, yes, you need to use your 3. Yes, you need to use your 4. But can I get a hand in there? Do you remember what slope looks like? What does it look like? Rise over. Oh, thank you for saying rise over again. 3 over 4. Perfect. How many? Oh, yeah, I remember that. You good with slope? Because this comes up on your assignment. So make sure you're asking if I lose you. Okay, let's find the slope of C to D. Okay, so don't count this. Go up 1, 2, 3, 4, 5, 6. Over how far? 1, 2, 3, 4, 5, 6, 7, 8. Do you guys agree with me?
Yeah.
Alright, so slope of CD is 6 over 8. Ooh. What do you think? Are those parallel or not?
Yes.
They are? Why are they parallel? How come?
If you simplify the fraction of 3 over 4.
So we can simplify this. Divide by 2. Numerator, denominator. Same thing. Okay, if it asks you to explain, guys, would this work and this picture be enough of an explanation? Yes, definitely. That's good enough. How many of you? I got that. Can you handle slope? So check. We've done the first part. We've shown that they're parallel because they have the exact same slope. Now the next part, your solution in your notebooks is like forever long. Have you noticed? So much going on, and you know already, I don't love filling in someone else's work. So let me erase what I've done on here. First thing that it asks you to do in your notebooks is use the midpoint formula. I would say you're not using your time wisely. Because do you really need the midpoint formula to find this point? Can you just look at the graph? Be nice to yourself. If there's a graph, just look at it. So let's write it on here. Actually, can I get a hand in there? Where's F? Look at it in your book and then tell me the coordinate for it. Count out from 0. And where is it? I agree. Okay, write it right on there. So here's F, negative 3, 1. Now we also need to know G. Yes, you can use the midpoint, find the middle of E and D, but might as well just use the graph and look at it. Okay, hand in here. Can you tell where G is? Calvin, where is it? I agree. 1, 4. Yeah. We okay being nice to ourselves? Okay, now the next directions is you've got to figure out that FG is half as long as CD. Dun dun dun, here comes the distance formula. You have to show your work with distance formula. So honestly, if it was me, I noticed that there's lots of space in your margin, kind of by the hole punches. I would probably turn my book sideways and start showing the distance formula. So let's find the distance of FG first. So D stands for distance. If you forgot the formula, I'll put it up on the board. Take your second x minus your first one, square it, plus your second y minus your first y, square it. Go ahead, get a deal. Alright, so for finding FG, we want to use point F and point G. It doesn't matter which one you use as the x2 or x1. I'm just going to look at it. I'm going to do this one, negative 3 minus 1. Don't forget to square it. Plus, let's see, 1 minus 4. Don't forget to square it. And then you can just go from there. If you've got this, keep going. I don't mind if you get ahead. Question, Colton?
Can you do F first and then?
Yes, you'll get the same answer. That's a great question. So if you use the other one first, the other coordinate, you'll get the same thing. Okay, negative 3 minus 1, that's a negative 4. I'll have to square it. 1 minus 3 is negative 3. Don't forget to square it. So that'll be negative 4 times negative 4 is a positive 16. Negative 3 times negative 3 is a positive. Oh, nice. Guys, what's the square root of 25? 5. That came out super nice. How many of you beat me to it? Good. Okay, do you remember from our activity? If this is 5, what should this one be?
10.
It should be doubled, right? So we gotta use distance formula, you gotta show it. So now do the exact same thing, use the distance formula, but find it for CD. Use CD's points. Okay, try to beat me to it. I'll show my work on the board. Okay, so there's two big things. One, slope. Will you vote with your thumbs, guys? Thumbs up. halves down. How are you on slope alone? Are you okay with slope? Let me see your thumbs. Okay, thumbs down. What about distance formula? How are you on distance formula? Did I ask for that? Okay, perfect. Let's go to the next part. Okay, this is what we've already learned through our patty paper construction activity. This part is new. DE, wait, do you know what these symbols mean? Okay, perfect. So DE parallel to AB, as we learned today, they'll always be parallel. Mid-segments are always parallel to the other side of the triangle. And then in the activity we talked about this, DE is always going to be half of AB. Always, super great. But get ready, I'm going to sneak in a problem on this. Because I don't think it comes up later in your notes, but it is on your assignment. What if they gave you that DE, this piece is 3x plus 1. What if they gave you that this whole leg is 10x minus 6? Okay, it's the same concept, but now we've got to use our algebra skills. Okay, this piece right here, if it was 3, what would this whole thing right here be? You just double it, right? So I don't have nice, easy. Take this and double it. 3x plus 1, do you know what that is doubled? Yes, double it. 6x plus 2, guys, I would totally copy this down on my notes. Get this down, because there's like 3 problems like this on your assignment, if not more. Okay, now that it's doubled, it will equal this one. Okay, so just use your setup. After you double it, then you can set it equal. Okay, go for it. Solve it. Pros at this. Oh, you got the same thing. Give me a thumbs up if you got the same thing. Will you be okay with that? I have a question for you though. I don't mean to confuse you. So double this and equals this. Technically, could you cut this in half? Is that equal to that? I don't know if it's harder. You just have to remember. I would say look at it and do whatever's easiest for you. Double something or cut something in half. Okay, let's see what's next. Oh, I left the solution on there. That's an accident. All right, but also we can figure this out without the help. So they're mid-segments. What are we looking for? We're looking for ST right here. Oh, here's your clue. Because if this whole thing is 30, what's just this little piece? Perfect. And this piece? So slide on up. This piece would have to be. There you go. Okay, done with that one. So ST is 15. Okay, over here, what else are we looking for? PR, where is it? Oh, this whole thing? Here's your hint. If this is 20, what's just this piece? So this piece? So the whole thing? Yeah, I agree with you. Okay, how many of you are like, give me those problems all the time. I can get those ones. Yeah, you okay with that? Perfect. Okay. Oh, another one. It's good practice. So again, we're going to do slope. Deep breath, and then distance formula. Let's do slope first. Okay, from M to N, remember you're dropping a balloon. You let go, which way does it go first? So go up, don't count this one. Up how far? I agree. And then backwards how far? 2. And it's backwards, so it's a -2, right? So slope of MN is -3 halves. Alright, so let's find the slope of JK. So here's J, here's K. Go up first, don't count this one. 1, 2, 3, 4, 5, 6. Back, don't count that one. 1, 2, 3. Oh, perfect. So the slope of JK is -6/4, which simplifies to what? So what do you think? Are they parallel or not? They're good, they're parallel because they're the exact same slope. Okay, you've only done half the problem though. Here comes the distance formula. Same thing, if you need more room, find space on your notebook, so do not mind. Okay, now yes, you can use midpoint formula, however, you don't have to. Can I get a hand in there? Where's M? Look at your grid and then find the point of M. Where is it? Christian, where's M? Perfect, write it in there. So M's at 2, 1. Okay, be careful with N. These are classic points that get flip-flopped. Do you know where N is? Do you know the name of that point? Tyler, what is it? It's 0, 4. It's not 4, 0. It's 0, 4. Okay, go for it. Start showing distance formula. Same thing as before. I'll show the work on the board in case you need a little extra help, but try to do it on your own. It's really good to try to challenge yourself. Did everybody get MN yet? 3.6? Okay, I highly suggest, like Annie just did, change it to a decimal. It might be hard to decide if it's not a decimal, but she said it's 3.6. Okay, keep going. Do the same thing, but do it for JK. You know how to get the square button on your calculators? Those of you who don't have your calculators open, you're making me nervous. Open them up, test it out. Definitely change that one to a decimal. They might have one on the board. Oh yeah, score button. Right, 52. Whew. Okay guys, look at the board in yellow. What do you think? Is one half as long as the other? Yeah, it's a little bit easier to tell once you take it out of the radical form, change them to decimals. Okay, so that's our second example. Yes, you're going to have one on your assignment. Are you guys feeling a little bit better about it? Okay. Let's jump around a little bit. Okay, these ones, super fast. Are you ready? Okay, if this is 28, guys, what's this one? Done. Cut it in half, right? So BC is 14. All right, this one, XC, where is it? Oh, this whole thing. Check it. Look, if this is 28, what would this whole thing be? You know? Yeah, good job. Double it, 56. Nicely done, Kevin. You can just double it or cut it in half, depending what they give you. This one, let's jump over this one. So I think this is top of page, I don't remember, but we're skipping it. Are you ready? So don't do this one. Well, let's definitely do this one. Okay, I've covered up my graph because I already did it. Because what you need to do first, we're on the bottom of page, what is it? 107. Again, we're on the bottom example, bottom of 107. What you want to do first is graph those points, and then we'll go from there. So graph letter D, letter E, and letter F. Go, Josh, go. Graph those points. Bottom of page 107. Skip over the top 107. Let's go to the bottom. And then connect them, should make a triangle. Wouldn't hurt to label it D, E, and F. Okay, the tricky thing about this one is that's a picture of your mid-segment triangle. It's not the bigger picture triangle, so how do you figure that out? Okay, there's shortcuts to this. I always find a leg that's right on the grid. Do you have a leg of the mid-segment triangle that's right on the grid? Count it out then. How long is it? Without using the distance formula, since it's on the grid, you should be able to figure out how long it is. I agree. Let me show you. It's going to give it away, but I'll show you anyway. Okay, so this is what I did. So this piece, this is what you're saying is 3, right? So what does this whole thing up here have to be? The whole thing has to be 6, yeah? But E's the midpoint. So go up to E and count 3 backwards. That's a vertex. Go back to E, count 3 out. 1, 2, 3. That's another vertex of your triangle. Check it. You have 2 of the vertices. You just need 1 more to connect it. Okay, this one, I just kind of use my fingers. You okay with that? So I put my fingers right here and I slit out to match up the vertex that we already have at the midpoint. Slit down. It's got to be on the grid. Tricks to the trade will totally work. And then you have your big triangle right here. So lesson from this one, if you have a piece of the triangle right on the grid, use it to your advantage. And then go back and up. You can work backwards from this. One more problem and we'll call it good. You talked about it before when we listed stuff that we remembered from Friday's activity. Into context. Up to number 4. So I think this is the very last problem in this chapter in the notebook. Okay, this whole thing is 11. If this whole thing is 11, what's this one? Yes, it is. Write it in. Okay, what if this whole thing is 10? What's this piece? Okay, write it in. Write it in. Okay, lastly, if this whole piece is 7, what's this piece? Okay. Now, what they're asking you to do is find the perimeter of the little triangle. And then find the perimeter of the big triangle, and we're just going to compare them. You probably remember the comparison, but humor me. Okay, perimeter of the little, you're just adding up the insides. 5.5 plus 3.5 plus 5. Okay, shut out, what is that? I agree, 14. Perimeter of the outside, 10 plus 11 plus 7, what is that? 28. If we're just comparing perimeters, what's the relationship? Half and half. Now, perimeter, don't get confused by that, guys. Perimeter is like building a fence around something. If we're talking area, does that make any sense? No, because it would be like there's 4 of those triangles. Yeah, be careful with that. You're buddied up for a reason.